Hello guys, before we start, let me introduce myself. I'm a professional big data trainer and working in big data industry for last 8 years. Teaching is my hobby. That's why I have created these videos. In my training program, first I work on theory part, then work on practicals. Each training program contain at least 100 to 150 practicals or coding examples and industry projects. I also work on interview question after completion of the subject. So before making any delay, let's start today's topic. So guys, before we have discussed about a little bit understanding of what is a Spark is and what are the features and what is the difference between Spark and MapReduce. And today we'll discuss about the component architecture and how these components communicate between each other. So in this video we will understand Spark execution in cluster mode, how things are really getting executed, and how many different components are there which are actually take part in this process. So before we jump into the Spark, let's get some understanding of yarn execution. How an application is executed in yarn. In this image you can see there are multiple boxes. Each box has its own purpose. Here you can see that two clients are submitting their application to the yarn cluster. These clients can be two different users with their different computers who have written their separate MapReduce jobs and are submitting their jobs to the yarn cluster. In yarn, when somebody launches his or her application, in our case I am assuming application as MapReduce jobs to yarn cluster, the resource manager scheduler allocates one container for its application master. So here you can see I have two application master, one is the pink color, one is the blue color. So pink color application master is for the client application, for this client application, and blue color application master is associated to this client application. We know that there is a one-to-one mapping between yarn application and application master, right? It means each application had its own separate application master. Here which takes care of its application. So take care of means that application master works on behalf of the application and try to fulfill all its resource demand on a regular basis. So let's come to the point. RM accepts the application from the client and allocates an application master, right? AM is a Java process, so it allocates the container for any node manager. So it allocates the container for its application on any of the node manager. So when application master gets started, it asks for the resources from the resource manager for its application task. So here is asking for the resources from the resource manager for its application. I have already told that this works on behalf of the application. Now look at the left image and see how this yarn concept works with the Spark. So there is some similarity. You can see that here you can see there are three boxes. Here you can see there are two boxes, one box. So there is something similarity. Something is similar. So you can map. This is almost similar to this, right? And this client section belongs to this. If you map the things. Here yarn works as a cluster manager, Spark context works as a client, and driver program is considered as an application. So driver program is an application which will be submitted by the Spark context on the yarn cluster. node manager will be called as worker node, and you can map the container to the executor. So one executor takes one container. So if you remember that in MapReduce, one container is allocated to one mapper task, either one mapper task 2 and one reducer task. But here one container is allocated to one executor, and one executor can execute multiple tasks. So Spark take care of resource scheduling and resource utilization as well. So in one container it can execute multiple tasks. Spark context, which is a client in this case, connects to the cluster manager, which allocates resources across the application. Right. So since Spark context is a client, here this was the client, so it sends application. So Spark context sends application and is asking for the resource manager to allocate the resources for its application. So here cluster manager, which is nothing but Yarn, will allocate one application master for the driver program. Because in our case, in Spark, driver program will be considered as a single application. So cluster manager means Yarn will allocate one application to the driver program, and after that driver program with the help of application master will ask for the resources to for its executors, and executor finally execute the task. How many tasks will be executed into a single executors, that will be configurable. So when connected, Spark acquires executor nodes in the cluster, which are processes that run computation and store data for your application. Next, it sends your application code like jar files, which are passed to the Spark context to the executor. Finally, Spark context send tasks to the executor to run. Right. So here you can see that this is my simple program. Here I am creating lines from the word.txt. So SC is a Spark context, right? And what is the driver in this case? The program, the main function in which this complete program is written is called the driver program. So where the function in which you initialize the Spark context is called the driver program. And this is the transformation. Filter equal to lines.filter lines or contains word 1. This is the transformation, and this is the action. So when you call the action, so what happens when you call the action? So Spark creates the directed acyclic graph for all the RDD used in this program. So what is the RDD means? When you apply any transformation, then Spark creates a new RDD. Here you can see lines is an RDD, filter is an RDD, right? So these are the RDDs. So before submitting the program to the cluster manager, Spark context create the directed acyclic graph for all the dependent RDDs, right? So we will cover these things in future videos. In the next videos, we will see how these this program will be broken into multiple stages and multiple RDDs, how RDDs are connected, how this will be submitted to the cluster manager and all. So here I tried to explain the similarity between the Spark program, Spark component diagram, and Yarn component diagram. So there are several useful things to note about this architecture. So each application gets its own executor processes, so which stay up for the duration of the whole application and run tasks in multiple threads. So what does this mean? If you launch an application, so each application have its own Spark context, and Spark context create the executors to execute this task. So these executors will be up till the time your programs get end. This has the benefit of isolating application from each other. On both the scheduling side, each driver schedules its own task, and executor side, tasks from different application run in different JVM. So however, it also means that data cannot be shared across different applications. So what does it mean? It's mean that each application has its own Spark context. So if you have a different Spark context, then it means you have a different driver. So if you have a different driver, so it will create the different task, and there can be multiple executor running on a single worker node. It's not necessary that you are using a single Spark application. You can have multiple Spark application which are going to be run on these worker nodes. Let's say you have a cluster of only 2 nodes and you have multiple applications. So all the executor will be launched on these 2 nodes. So what I'm trying to say that when you have a different Spark context, then you will have a different driver program, because each driver program has its own Spark context, and Spark context will allocate the executors for its application, different executor for different applications. So let's say if multiple executors are running on this worker node, so they will not be correlated, they will be isolated, they will not share their data between each other. They can share, but there is a property in which we can share our Spark context between multiple Spark applications. So that is the different thing, but it is recommended not to share a Spark context between multiple applications. Spark is agnostic to the underlying cluster manager as long as it can acquire executor process and these communicate with each other. It is relatively easy to run even on a cluster manager that also support other applications. So not only the yarn, you can run your Spark program on Mesos, and one thing is the standalone. The standalone means you have to monitor resource utilization. So which kind of helps we are getting from the yarn? So yarn works as a resource negotiator for us, right? That's why most of the time people use Spark with the yarn. So driver program must listen for and accept incoming connection from this executor throughout its lifetime. As such, the driver program must be network addressable from the worker nodes. What it's trying to say, when you launch your program, so there should be a connectivity between driver nodes and worker nodes, because they communicate all the time, because the driver schedule task on the cluster, so it should be run close to the worker node, preferably on the same node. So I am going to stop here because it was the component diagram, and in next video I will discuss about all the components, how they actually works. So guys, that was all about today's topic. Please do write your suggestion in the comment section. Please not to forget to subscribe to my channel for getting the latest updated videos. Please click on the bell icon. Happy learning.